I'm back again. Let's continue our study of electron configuration. Now, I want to talk a little bit about Hund's rule, okay? And as I do, I'm going to ask you, how many of you have played cards before? Now, when you're dealing a deck of cards, what do? You start and you go all the way around and you give everyone one card. And you don't give anybody two cards until everybody has one card. So if there's 4 people around the table, you go 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, and so forth, right? And if you know anything about Blackjack, and I'm betting all of you have played Blackjack or seen it at least a few times, when you're dealing Blackjack, you've got people around a Blackjack table, and what do? 1, 1, 1, 1, and then 1, 2, 2, 2, 2. And it's 1 down and 1 up. One face card, 1 card down, 1 up. 1 card down, 1 up, right? So, I want to put those two concepts together as I talk to you about Hund's rule. Now, if you read Hund's rule in your textbook, it's really confusing. Hund's rule, according to Hund's rule, electrons occupy orbitals of the same energy in a way that makes the number of electrons with the same spin direction as large as possible. What in the world does that mean? Well, I'm going to take a little game of Blackjack and I'm going to help you understand. Okay? Now, if I deal my Blackjack, I'm going to deal my Blackjack 1 down and 1 up. Okay? So this card is face down, this one's face up. That's how we're going to do that. So, I come to the first table, and let's say I'm a dealer at Las Vegas, and I'm at the Blackjack table, or in the Blackjack room, and somebody comes up to the first table and says, we want to play. And so the dealer comes up and says, all right, here you go. 1 down, 1 up, you're in. Now, somebody else comes in, sits at the second row by themselves, says, I want to play 2. Dealer says, okay, 1, 2, you're in. Now, somebody else, there's a group of 3 people that come in, okay? They sit down at this table, it's a bigger table, and they say, we want to play 2. It's like, all right, 1, 1, 1, 2, 2, 2, right? Then somebody else comes in and says, I want to play. So he says, okay, let me deal you in. 1, 2. Somebody else comes in over here. A group of 3 comes in and says, we want to play 2. 1, 1, 1, 2. Oh man, I'm out of cards. I don't have any more cards. Now, let's look at what happens here. I've got the first energy level and the s orbitals. I've got the second energy level, I've got the s orbitals and the p orbitals. I've got the third energy level, the s orbitals and the p orbitals. Now, how many do I have here? I've got 2, 4, 6, 8, 10, 12, 14, 15, 16. I've got 16 electrons. How many unpaired electrons do I have? I've got 2. I've got 4 p electrons, but 2 of these electrons are unpaired. Why? Because I put 1 in each orbital before I came back to put 1 into a second orbital. 1 down, 1 up. 1 down, 1 up. 1, 1, 1, 2, 2, 2. 1, 1, 1, 2, 2, 2. 1, 1, or 1, 2. 1, 1, 1, 2. No more cards. Okay? So I have got the maximum number of unpaired electrons. Let's say that I had 3 p electrons. Okay? Instead of having 2 paired and 1 unpaired, I would have 3 unpaired electrons. Why? Because I'm going to put 1 electron in each orbital before I go back to put in another electron. And that's the concept of Hund's rule. Blackjack. 1, 1, 1, 2, 2, 2. 1 down, 1 up. And there you have it.